Howdy everyone, I'm Jiahao. This is my research presentation. The paper I will present today is called Visualization by Demonstration, an interaction paradigm for visual data exploration, and below is the list of authors. There are 5 sections in the presentation. The first section is called Motivation, Why it matters. The second section is called The Explanation. What exactly is visualization by demonstration? The third section is case presentation. It will show some possible cases of the software and the paradigm design. The fourth section is background mechanism. It will explain some background algorithms and the recommendation system behind. The last section is called evaluation and critics. For motivation, although data visualization tools are always getting better, many of them still require users to manually set visualization techniques, mappings, and parameters during the data exploration process. For example, remember in Tableau, we need to manually set up the XY axis and specify the visualization we want, adjusting parameters, etc., which brings big inconvenience to users. Also, you can think about things happening in design for understanding, in which we can easily produce some idea to visualize the data, but it takes hard effort to show exactly what you want. Like in design for understanding, I want to design a group of pie charts. I can easily sketch it in 10 minutes, but it took 2 to 3 hours to really implement it in Tableau. This paper also criticized visualization software like Tableau. Such visualization systems allow users to specify direct mapping between their data and the visual representation without requiring users to have programming skills. However, such systems require some amount of fundamental knowledge about the data, the domain, and of visualization techniques. All of the above shows that current visualization softwares need to be improved. This paper utilized the concept of visualization by demonstration to redesign the visualization software. So, what exactly is visualization by demonstration? Visualization by demonstration is a way of interacting with visualizations that permits users to visually demonstrate small changes or partial mappings, enabling them to construct the visual representation more easily. In short, visualization by demonstration allows users to manipulate components in visualization, so that based on users' action, the system will do some adjusting to achieve the user's desired visualization. In order to implement a paradigm for visualization by demonstration, there are some guidelines we need to follow. The first guideline is supporting direct manipulation of visual representations to foster visual data exploration, which means the users can directly manipulate those components in the visualization. The second guideline is balancing human and machine workload in the visual data exploration process, which means both users and the system will do equivalent work in designing the visualization. The third guideline is enabling user interactions to drive recommended transformations. This means based on users' action, the system needs to change the visualization accordingly. The fourth guideline is enhancing interpretability of recommendations. This means the recommendation system needs to provide reasonable adjusting results. Here is the software they designed, and this is the main page. On the main page, we can see that there is a large sync board at the center of the panel. It shows the main visualization. There is a detailed view on the right side, which shows all the properties and attributes for each data point. Also, we can see there's a recommendation galleries at the bottom of the panel, which shows other possible visualizations for the dataset. Okay, let me show some simple actions for this software. And let's get started with data point selection. Suppose our dataset is about cars. Suppose we want to select 2 cars. Then 2 data points corresponding to 2 cars will be surrounded by dotted line. After the users drag these 2 data points in a column based on the data position, the paradigm will recommend a list of possible XY coordinates options. Then the user can select desired attributes to corresponding coordinates. Assuming the user selected vehicle length as the x-axis, because both data points represent vehicles that are 175 inches long, we can infer that the recommendation system pushed vehicle length as a potential attribute, because these 2 vehicles have the same length. The left side shows that, suppose we want to color 2 cars. There is a drop-down menu. Will show all the possible attributes. Then suppose you want to select the number of cylinders corresponding to the colors. Then the result will be in the right side. The left side shows that suppose the user wants to stack scattered points in a column, then the bar charts will be shown below as recommendations. The right side is after the user chooses one of the possible visualizations. We just saw some runtime examples of the paradigm, like how it works, but what is the exact internal recommendation engine? The first mechanism is position interpolation. After a position changing interaction, the system searches for data attributes to assign to the axis in a scatter plot based on the positions of the moved data points. For example, if you move the red point in between blue and green, then for the x-axis, the attribute miles per gallon will be recommended. The second mechanism is called resizing interpolation. When the user resizes a data point in the scatter plot, the system interprets it as the users interested in encoding a data attribute to the demonstrated size of data points. However, here are something you need to notice. In order to provide enough information to the system for recommending a mapping from data attribute to the data point sizes, the user has to resize 2 or more data points. The third mechanism is called coloring interpolation. It defines an attribute as categorical if number of unique values represented is fewer than 10 and fewer than half of the number of data points. There's a principle called inclusion and exclusion principle. For example, 2 data points representing cars with attribute values given by the tuple. The first car is AWD sedan, 6 cylinders, and the second car is FWD sedan, 6 cylinders. Both first and second car are colored red. The third car is colored blue, which is AWD sedan, 4 cylinders. Then the system recommends mapping the cylinder's attribute to color by coloring 6-cylinder car red and 4-cylinder car blue. So which means the recommendation engine would assign number of cylinders to colors. After briefly introduce the paradigm, let's review and critique. I think this is an overall good design, because this design greatly mobilized the subjective initiative of users. Like I said, we can come up with some idea in few minutes but take a long time to implement it when doing the design for understanding. However, it's gonna be a big lifesaver if we use this software to design for understanding, in which this software will easily translate our intentions. However, I would suggest that currently this software can only translate users' idea into traditional charts, such as bar charts, line charts, and etc. And some novel charts cannot be implemented. For example, a group of pie charts cannot be created. In contrast, Tableau is more friendly toward displaying those innovative charts. Remember we mentioned the 4 guidelines before, where the paradigm should satisfy the 4 guidelines. So let's go over the guidelines to see if they are really satisfied. The first guideline is supporting direct manipulation of visual representations to foster visual data exploration. I think it is satisfied, because the users can move the position of data points, recolor data colors, and adjust data sizes, etc. The second guideline is balancing human and machine workload in the visual data exploration process. I think it is satisfied, because in order to let recommendation engine provide some examples, users need to think on how to change those data to lead the recommendation engine give the desired results. The third guideline is enabling user interactions to drive recommended transformations. It is satisfied because the recommendation engine will provide a list of possible samples to user based on user's operation. The fourth guideline is enhancing the interpretability of recommendations. It is satisfied because the mechanism for recommendation engine will make a decision that is based on the property relations of changed data. So, all 4 guidelines are satisfied. In sum, in this presentation, I talked about the motivation of visualization by demonstration and explained what is visualization by demonstration. Then we saw some possible examples of the paradigm. Lastly, we did some evaluations and critiques about the design. So here are references. If you have any questions, please comment out in Slack. Thank you.